Stars are the most common objects in the universe, and in the next video I'll describe more about what they are, how they work, and what we can find out about them. Here I will talk about the life cycle of a star, how they come about, live, and then die. And in this discussion we will encounter some of the most outrageous features of our universe, the likes of black holes and supernova explosions. To start with, just picture a huge cloud of hydrogen dust. Gravity will mean that slightly denser areas of the dust will attract more dust. This in turn makes these areas even more dense, and so they have even more gravity to pull in more dust, and so on. As more dust comes in, these areas heat up. This is clearly a snowball effect that eventually results in a few areas where the dust begins to shine like a star. This whole region of dust is called a nebula, and it's known as the birthplace of stars. Once these stars have been born and have accumulated enough of the surrounding mass, they enter a steady state of burning hydrogen and shining bright. The gravity pulling in on the star is balanced by the outwards pressure of all that is going on within it, and it will stay in this balance for about 10 billion years. This section of a star's life is called the main sequence, and our Sun is currently in this section. Eventually, however, the star will run out of hydrogen fuel, and depending on how massive the star is at this stage, it will undergo different final stages of its life. Let's first look at stars of a similar size, or smaller than, our Sun. When such a star runs out of fuel, the outward pressure created in the star starts to decrease, and so the gravity starts to collapse the star in on itself. As it collapses, the outer layers try to escape and actually expand out, and in doing so they cool down. The result as we see it is a massive red-looking star, since we only see the outer layers. We call this a red giant. Eventually these outer layers expand out and disappear, and what we're left looking at is the core inner section of the star that has collapsed in on itself. We see that it has found a new settling ground. What is left of the star can exist as a small, extremely hot ball of mass, which we call a white dwarf. This is the retirement home for a normal-sized star. Now we look at more massive stars. In a similar way, we see that when they run out of fuel, their cores start to collapse, whilst the outer layers try to escape and cool down. Since this is on a much bigger scale than before, we now call what we see a red supergiant. The core of these supergiants continue to collapse and collapse until something remarkable happens. There reaches a point where the collapse causes an astronomical explosion, which we call a supernova. This supernova explosion is so bright that it outshines the whole galaxy that it is part of when we see it. It clearly releases an unbelievable amount of energy, and it is in this high energy process that heavy elements like oxygen or carbon can be created in abundance. This is why it is said that we are made from stardust, since the elements that are essential for life and occur on planets like ours must have originally been formed in a supernova explosion. What is left after the supernova? Well, again it depends on how massive a star we're talking about. For a pretty massive star, what remains is called a neutron star, which contains the mass of more than the Sun in a sphere that has a radius of just about 30 kilometers. Think about that for a second. The whole mass of a Sun, maybe 500,000 Earth masses, packed into a sphere that could fit into London. Neutron stars are truly remarkable objects, and I recommend reading some facts about them. If the star is supermassive, however, not even a neutron star can form. The gravity is too strong and nothing can stop the collapse of the core, and what is formed is a black hole. These mysterious objects form a spherical ring around them, which is a barrier of no return. Once anything, including light, crosses this barrier, it is physically impossible to overcome the gravity of the black hole and so it cannot escape. Since not even light can escape them, this sphere is completely invisible, and we only notice their presence by the effects they have on other objects. We never see a black hole. This boundary we see is called the event horizon, and what happens inside this invisible sphere is one of the great mysteries of physics.